This video will cover the contents of section 19.2, quadratic functions and their graphs. A quadratic function is very similar to a quadratic equation. It has a different notation, which we've seen before for function notation using an f of x representation. And we've seen the quadratic that takes this form, ax squared plus bx plus c. So it's a second degree polynomial, meaning we have an x squared. And that's pretty much the key to what we're doing here, having an x squared in our function. Every quadratic function has a U-shaped graph, otherwise known as a parabola. And it will open either up or down, and we're going to cover ways to discuss which way it is. So it takes on the shape of a U or a parabola. One key indicator we will discuss is the value of A is going to trigger whether the parabola opens up or down. If A is greater than 0, the parabola opens up. And I use the notation, an analogy of if A is greater than 0, that means A is positive. We think of positive things as good things, and we think of good as smile on our face. A parabola which opens up is like a smile, a happy face. If A is less than 0, it is negative. We think of negative things as being bad things, which means we frown, which means it opens down like a frown. So that's just a little trick to help you decipher whether the parabola opens up or down. It will be driven by the value of A. If it's positive, that's happy, that's good, it's a smile, which opens up. If A is negative, that's bad. It means frown, opens down. So here we have a graph of a quadratic function. You can see that it opens up. And I want to identify a few vocabulary words here. The vertex is the point where it transitions from going down to going up, or in the case of a parabola that opens down, the vertex would be the transition point from increasing to decreasing. It's a maximum place or a minimum place on the graph. It's a minimum value in this case. So it's the highest or the lowest y coordinate on your graph. The axis of symmetry, if you imagine a line, a vertical line that cuts right down through this vertex, that's what we call the axis of symmetry. And it divides the parabola in half. So the right half of the parabola is a mirror image of the left half of the parabola. So everything on this side is identical to this half. So to define the axis of symmetry, it's going to be an equation that defines this line. And we decided that in graphing, we learned that a vertical line has the characteristic that it will be x equals some value. We know the vertex point, which I didn't write it up here, but the lowest point has coordinates 1, -4. The vertex is an ordered pair point, 1, -4. The x value is 1. So the axis of symmetry will always be the equation x equals, and it will be the value of the x coordinate of your vertex. So axis of symmetry will look like x equals 1. The y-intercept is the place where the graph crosses the y-axis. So if this is our y-axis, the spot where the graph crosses is right here at point 0, -3. So the y-intercept is -3. If you're asked to put it as an ordered pair, it would be a coordinate point 0, -3. The x-intercepts, oftentimes there are two. In this case, there are two. There are two places where the graph crosses the x-axis. There could be a time where it touches right on the axis at one single point. In that case, you would have one x-intercept, or you could possibly have a parabola like that that never touches that x-coordinate. So this would have one x-intercept. This would have no x-intercepts. And the example before us has two x-intercepts. There are the x-coordinates of the points where the graph crosses or touches the x-axis. So it crosses at point -1, 0, which is this point right here. And it also crosses at this point 3, 0. So the x-intercepts are -1 and 3. The domain of every quadratic function is all the real numbers, which is represented this way. Because if you look at any point, x point along the graph, it would have a corresponding y value. This corresponding x has y value of 0, 4 has a y value of 5, 1 has a y value of -1, or -4, I'm sorry. So determine the range, you're trying to draw a box around the minimum and the maximum point. If you can see the lowest point on the graph, that's the lowest point of your range. So the y value of the vertex is -4, so that would be your low end of your graph, and this continues to go vertically higher forever and ever. As these lines continue to go, it will go to infinity. So the domain is always -infinity to +infinity because these spread out. The graph is getting wider and wider to the left and the right. So there's no ending to the left boundaries. The y boundaries, what defines the range. So the range, you're going to use the y value of the vertex as your stopping point. Now I'm going to actually change this to a straight bracket versus round because 4 is actually included in the set of points. So if you have a minimum vertex number, your range will start with -4. If you had a parabola that had a maximum value, and let's say this point was 2, 8, then since it's a maximum, your range would be, this would be the maximum number, so you're going to have 8 as a maximum and -infinity as a minimum. So one will always be infinity or -infinity. The other will be the y coordinate of your vertex for the range. We're not going to cover translations in this segment or vertical shifts. Or horizontal shifts. We're also not going to cover the section that discusses completing the square. So if you're follow along in your guided notebooks, we're going to skip objective 3, objective 4, objective 5, and we're going to pick up on objective 6, where I'm going to show you exactly how to find the points that I just discussed. So the first thing, and one of the most important things, is to figure out how to calculate the vertex of a parabola. Now, if you have memorized the quadratic equation, which is -b plus or minus square root of b squared minus 4ac over 2a, then it's easy to find the vertex because you just grab this peanut-shaped piece from the quadratic equation. Basically, you get everything except the square root. So you use -b over 2a to get the x coordinate of your vertex. So if you had a function that looked like this, f of x equals 3x squared minus 12x minus 4, a is 3, b is -12, and c is -4. So putting b and a into this here, I would have, and you have to be careful because this is a forced negative sign here, and if b is negative, you end up with a double negative, which makes a positive, so you have to be very careful about that. 2 times a, and a is 3. So you have a positive 12 over 6, which is 2. That will be the x coordinate of your vertex. So we know the vertex will be 2 and then some value. And then just like anything with finding points, if you know the x, you can plug it into your equation, or in this case into your function, and get its corresponding y value. So just like if we were doing linear equations and we were plotting, if we knew x was 2, we would put it into the equation, calculate the value for y. That's the same as using a function notation, which is also the same as saying f of 2. So we put 2 into this equation. So 3 times 2 squared minus 12 times 2 minus 4. This is 3 times 4, so I have 12 minus 24 minus 4. -12 minus 4 gives -16. That will be the y coordinate of my vertex. So again, you get -b over 2a, calculate the value for that. That gives you the x coordinate of the vertex. Plug that into the entire function, not into here, but into the function. Put 2 into x here and put 2 into here and calculate your y value. So another example using this function here in front of you. A is -1/2. B is -10. And for vertex, I only need a and b, so I have -b over 2a, which is, again, a double negative because I have the negative that goes with the b, and then b is a -10 over 2 times -1/2. That gives positive 10. 2 times negative 1/2 is negative 1. So the x-coordinate of my vertex is negative 10. Now I have to plug that in to find the y-coordinate. So I plug it back into my function. So I have negative 1/2 times negative 10 squared minus 10 times negative 10 plus 5. I have to follow my order of operations. I cannot multiply these before I do exponents. I have to do exponents. So negative 10 squared is 100. Negative 1/2 times 10 is negative 50. Now I can do this multiplication piece. Negative 10 times negative 10 is positive 100. Now I have all addition and subtraction. Negative 50 plus 10 is 50 plus 5 gives me 55, which becomes the y-coordinate of my vertex. So that's how I find the vertex of my parabola. So if you want to graph a quadratic function, one of the key things you're going to do is identify the vertex, and then you're going to look to see if the graph opens up or down. So we have a number of steps of things that we're going to use to help us graph an equation, a quadratic function. So if this is the formula or the function we're going to graph, we're going to first see if we can find the vertex, which is once again negative b over 2a. So b is negative 4, so it'll be negative b over 2a, which is 4 over negative 4, which is negative 1. That will be the x-coordinate of my vertex. I will plug that into the function to get the y value. Negative 1 squared is positive 1. Negative 2 times positive 1 is negative 2. Negative 2. Negative 4 times negative 1 is positive 4. Gives me the value 7. So my vertex is negative 1, 7. So if I were to make a coordinate system, I don't know if I'll have room. Negative 1, 7 would be this point. Now at this point, I don't know if my parabola will look like this going up or if it will go like this going down. So I have to answer the question, does it open up or down? And if you recall, what we use to identify the direction is we look at the value of a. A is negative 2, which is negative, which means bad, which means frown. That means it opens down. So I know my parabola will be coming down from this maximum value. But I don't know how wide or how narrow. So that's where these other things are going to come in handy. The equation of the axis of symmetry is going to be, what's the equation of this line, this imaginary line that goes vertically down through here? The axis of symmetry is always x equals, and it always has to be x equals, and then you just grab the negative 1 off of the x-coordinate. X equals negative 1. If my vertex were 2, 3, my axis of symmetry would be x equals 2. If my vertex were -8, -10, my axis of symmetry would be x equals -8. Now we want to find x-intercepts. We want to know, where does this spread out? Where does it cross this x-axis? So this is where we have to solve for x. So in order to solve this for x, where it crosses this axis, we know that y is 0, so we can solve this following equation because I know where it hits this x-axis, the y-coordinate is 0. I have not gone up or down any, so I can set that equal to 0. And we've learned several ways to solve this for x. One way would be to factor this, and in this case you would have to use the AC method. The other way, I will use the quadratic equation because that's the section we've just been working on. So I would enter A, B, and C into my quadratic equation. So negative B is going to be -4 plus or minus square root of B squared. So that'll be 16 minus 4 times A times C all over 2 times A. Put this into your calculator and you get, I'm going to take care of the double negatives and make it a +4, square root of 56 over -4. I can't get a square root of 56, but I can simplify 56 and make this 4 plus or minus 4 times 14. I'll rewrite this here. 4 plus or minus square root of 4 times 14. So square root of 4 is 2. I leave the square root of 14 in here. Now I have a triangle of reduction, 4, 2, and 4, all outside the square root. It has to be these three outside of the square root. A 2 divides evenly into all three of those things, so go ahead and divide it out. 2 plus or minus 1 times square root of 14 over -4. Sorry, -2. Now, because we're trying to graph, this would be an exact answer. I want an approximate answer so I can graph it. So I'm going to get a decimal approximation from this and round it to do 2 decimal places. So that I would have 0.87 and I would have -2.87. Once with 2 plus square root of 14 over -2. 2 minus square root of 14 over -2, and I come up with my 2 x values. So my solving for x gave me these 2 values, and they each have associated corresponding y values of 0. And to plot those, I would just eyeball those. That's just a little less than 1, so that would be right in here. That's just a little less than -3, a little bigger than -3, which would be right in here somewhere. So now I know how narrow my parabola is going to be because I can hit the x-axis at both of these x-intercepts. The y-intercept, it appears right here to be 0, 3. But that's just a visual eyeball. That's also a helpful point to plot, because if you have a parabola that does not cross the x-axis, then the y-intercept might be more valuable than x-intercepts if you end up not having any x-intercepts. So the way you find the y-intercepts is you know that it crosses the y-axis at point x equals 0. So you just plug a 0 into your function and get the corresponding y value. So we're going to put 0 into this equation. So -2 times 0 squared minus 4 times 0 plus 5 equals 0, 0, 5. So I'm glad I didn't eyeball that, because I didn't draw that accurately. It actually crosses at 0, 5. So my parabola goes like this. It's a little more rounded, which is why we can't just look at these and eyeball them. So my y-intercept is 0, 5. And I just sketched the graph. I used the x-intercepts, I used the vertex, I used the fact that I knew it opened down. I plotted the y-intercept. And last but not least, we're going to state the domain and the range in interval notation. Interval notation is always two numbers separated by a comma, the low boundary and the high boundary. Domain of a parabola is always negative infinity, positive infinity. The range, remember, we're going to get the highest point of the vertex. Since this opens down, this is a maximum, so we're going to get the y value off the vertex, which is 7. Since that's a maximum value, it's going to go on the high side, and negative infinity will go on the low side. So domain, range. So this is the assignment I would like you to do. I want you to get your own paper. I want you to do problem 1, which is to solve this using the square root property. That's where you isolate the square, then take the square root of both sides. I want you to solve this question using the quadratic formula and make a note of the steps. You have to make sure it's in standard form first. Then I want you to take this function and I want you to identify the vertex, if it opens up or down, give me the equation for the axis of symmetry, identify the x-intercepts, identify the y-intercept, identify the domain, the range, and then I want you to graph the function using this information that you identified.